Hi class, this is Miss Hagen here, and if you recall, we are in the matrix unit of Algebra 2, and so far we have learned how to add, subtract, and multiply matrices by a scalar. Also, yesterday we learned how to multiply matrices. So if you remember yesterday, we kind of went over the basics, like we said, when can we multiply matrices? When is it defined? Is it possible to, when are the situations when we can multiply? So we looked at dimensions and we looked at sizes and stuff like that. And then we also, when it was defined, when it was possible, we figured out how to multiply the matrices. So, multiplying the rows and the columns, we actually learned the method of how. But we actually never went over why that works. Why are we doing this? How do we connect this into real world? Why does this method work? So that's what I wanted to do today. I wanted to give you guys a real world example where you can actually tie this in your real life. And use matrices in your real life to show data and describe data and even solve problems that way. So, to start it off, I picked this example. I thought it was relatable for you guys. Three students sold t-shirts for a school fundraiser. Short sleeve and long sleeve shirts were available. The table below shows the quantities sold by each student. Alright, so let's look at our table. Let's investigate our table right here. If we notice, we've got two columns. It's short sleeve and long sleeve, and then we've got our three students, Lily, Stan, and Kevin. If we read this table, it says Lily sold 20 short sleeve shirts and 15 long sleeve shirts. Alright, now Stan looks like he didn't do so well. He sold about 8 short sleeve and 6 long sleeve. And then Kevin looks like an overachiever. He sold 32 short sleeve shirts and 14 long sleeve. Alright, so we figured out how to read this table. Now let's use it, connect it using a matrix. So create a matrix for this quantity data. And then what are the dimensions of the matrix? We did this yesterday, so we know how this works. All you have to do is create, let's say A is going to equal, and we'll create our brackets. This bracket is going to create the matrix, so now we just have to plug in our data entries. We've got a 20, we've got an 8, and we've got a 32. Now in our next column, it's going to be a 15, a 6, and a 14. Close it with a bracket. So here's our matrix A. Now let's figure out what are the dimensions. So our dimensions here, it looks like we've got 3 rows by 2 columns. Remember when you define the dimension, you have to go rows by columns. So this is a 3 by 2 matrix. A is. Alright, so now let's move on. It says the table below shows the prices for the two types of t-shirts. And then I want you to create a matrix B for the pricing data and what are the dimensions of the matrix. So here, let's investigate this. We've got the pricing of our t-shirts. So it looks like a short sleeve shirt is going to be $10 and a long sleeve shirt is $15. Now if we go back to our matrix that we learned how to do yesterday, this is going to be pretty simple. We just have a 2 by 1 matrix because we only have 2 data points in one column. So therefore this is a 2 by 1 matrix. Okay, now let's zoom it out. Let's see what this question is really asking. Let's figure out what we're trying to solve. It says to complete this table to show the total revenue that was brought in by each student. So we're given this information. We're given how much the quantity they sold, and then we're also given the price of each t-shirt. And now we can use that information to figure out the total revenue. How much did each student make on this? So how we do that? Let's figure out how we would do this just by looking at the tables. We notice, let's just look at our category of Lily. Lily sold 20 short sleeve shirts and 15 long sleeve. We know the price of a short sleeve is $10, so let's multiply that by our 20. So it's going to be 20 short sleeve shirts multiplied by the $10. So Lily made $200 on just short sleeve shirts, on just selling short sleeve shirts. Now let's look at the long sleeve. She sold 15 at a price of $15. So we have to add that to her total revenue because it's also included. It's short sleeve and long sleeve. So it's going to be 15 t-shirt or long sleeve multiplied by $15. And that's going to give us, I'm running out of room on my table, but that's okay. That's going to give us a total of $425 that Lily made. All right, now let's look at Stan. Stan, we're going to do the same process. He sold 8 short sleeve shirts at the price of $10. So we just have to multiply those. That's going to be 8 short sleeve times $10. He made $80 on just short sleeve. Now, same thing with long sleeve. We're going to go 6 long sleeve times 15. Do the math and add those together, and we're going to get a total of $170. So Stan did not make as much as Lily. He only made $170. Lily made $425. Now let's figure out what Kevin made. He probably made way more, it looks like. So let's look at here. We've got 32 short sleeve times 10. We're going to continue this process. Looks like he already made $320 just on short sleeves. Now, long sleeves, he sold 14 at a price of $15. So do the math, and he ended up making $530. Alright, so there you have it. There's our values, our total revenue. If we were to look at this, Lily made $425, Stan made $170, and Kevin made $530. So now we can kind of analyze and interpret this data. We can describe this data too. Kevin made the most money, Stan didn't make as much. And now we can figure out, the total revenue of the group. But let's tie this back into matrices. So we can kind of figure out what we did. Let's call this new matrix C. And if we see, our final answer is going to be a 3x1 matrix. So our final answer is going to be 425, 170, and 530 here. If we look at that, that is a 3x1 matrix. Okay, so that kind of described why. Now let's tie this back in with the methods that we learned yesterday. So yesterday we just had two matrices and we multiplied them together. So let's rewrite that over on the side and see if we get the same answer. So our numbers were, A was 28, 32, 15, 6 and 14. Here's our 3x2 matrix. And we're multiplying that with our second matrix, which is B, which was a 10x15 matrix. Or 10 and 15 were the entries, and then that's going to be a 2x1 matrix, dimensions. Alright, so what we learned yesterday, we figured out the when can we. Is this defined? Is this matrix defined? Can we multiply these? So is this even possible? Well, what we learned yesterday, that it is, because the number of columns in A is equal to the number of rows in B. So since that's true, then we can multiply it. It is defined. And our new matrix is going to be a 3x1 matrix. So let's just say matrix C is going to be a 3x1. If we look back in our other example, we did finally get a 3x1. Alright, so now it is possible, now we can multiply. So what we learned yesterday, we did these steps where we took the first row in our first matrix and we multiplied it by our first column in the next matrix. That's going to give us our first entry here. Notice how it's in the first row and the first column. So what you do is you take 20 times 10 and then we're going to add it to 15 times 15. So I'm obviously showing more work than you need to, but just to be sure. So then that's going to give us 425. Now to figure out our second entry right here is going to be this middle one. We're going to take our second row and we're going to multiply it by our first column. Second row, first column, still in this matrix. So we take 8 times 10 plus 6 times 15. That's going to give us a final answer of 170 over here. And now our last one, let's use this color, we got 32 and 14, it's our third row, and now we're going to use it with the first column again. This is our third row, first column. So it's, you take 32 times 10, and we add it to 14 plus 15, or times 15. That's going to give us 530. So yeah, we went over this stuff yesterday. We did this method of, you know, we were given two matrices. We needed to figure out, can we multiply them together? Yes, we can, because it is defined. Our new matrix is going to be a 3x1 matrix. And then we use this method of multiplying, you know, the rows by the columns and adding them in between. So that's kind of the when and how, and then this is the reasons why this works. Here's a real world example of how we can actually use it. If we If we were given short sleeve and long sleeve data, we know that we have to multiply, like if we zoom in here, sorry, technical difficulties. We were zoom in here, we have to find the total revenue, we have to multiply this column right here, this 10 and 15, by both numbers. Okay, so to find that answer, $20 for 20 short sleeve shirts, we have to multiply it by the $10. 15 long sleeve shirts, we have to multiply it by 15 long sleeve multiplied by 15. That's going to get our... So you kind of see why this works in a real world situation. We can figure out total revenue, or even other examples. We can just figure out how to multiply our matrices. So I hope that helps. I hope that kind of explains why this works, why we multiply it the way we do. If you need more examples, I'll be happy to help in class, so let me know if you guys are stuck. But I just wanted to give you a rundown of why this works using a real world example, so we see how to multiply matrices. And have a great day!